Welcome to the Explainer. Today we're digging into a type of vulnerability that's, well, a little different. It's not a coding bug. It's actually hidden in the very blueprint of your software. It's called insecure design, and trust me, it can be a total disaster.
So get this. Picture a huge cinema chain. It's the opening night of a massive blockbuster. And then, all of a sudden, everything just goes haywire. In a matter of minutes, attackers managed to book 600 seats, not in one theater, but across every single one, all at once. It caused absolute chaos and, of course, a huge financial hit.
So the big question is, how on earth did they pull that off? You're probably thinking it was some super complex hack, right? Some clever exploit in the code, but nope. The vulnerability wasn't in the code at all. It was in the design. It was there from the very beginning, just waiting.
And that right there gets us to the heart of the problem. When security isn't baked into the initial plan, you're not just building an application, you're basically drafting a blueprint for disaster.
You know, the best way to think about it is like building a house. Imagine an architect draws up a blueprint, but whoops, completely forgets to include a foundation. Does it matter if you have the best construction crew in the world? Of course not. The house is doomed from the start. And it's the exact same thing with software. You just can't patch over a fundamental design flaw with perfect code.
So, to really get to the bottom of what happened with that cinema attack, we first have to understand the difference between two totally different kinds of problems. A flaw in the design versus a flaw in the implementation.
Okay, so according to OWASP, that's the Open Web Application Security Project, insecure design is all about missing or ineffective security control design. In plain English, for that cinema, the system was never designed to stop someone from making a massive, coordinated booking attack. That protection, that control, it just wasn't in the blueprint. And this slide really lays it out perfectly. A design flaw? That's a bad blueprint. The whole plan is just wrong from the get-go. But an implementation flaw? That's more like bad construction. The plan might have been solid, but someone messed up while they were building it. See the difference? You can fix bad construction, but you can't build a safe house on a busted blueprint.
You know, OWASP has this quote that just nails it. An insecure design cannot be fixed by a perfect implementation. I mean, let that sink in. You could have the most brilliant developers writing the cleanest code on the planet, but if that underlying design is weak, your application will always be vulnerable.
So just how big of a deal is this, really? Well, the data shows, get this, nearly 730,000 documented cases of insecure design flaws. This isn't some rare niche problem. It's a massive, industry-wide issue that we have to tackle at the source.
So, okay, if the blueprint itself is the problem, how in the world do we create a better one? Well, the solution really comes down to three key pillars. Think of them as the foundation for a secure structure. It all begins with Pillar 1, requirements. Before anyone even thinks about designing anything, you have to ask the right questions. What are we trying to protect here? What are the real business risks? For the cinema, that question should have been, hey, should a single user be able to book 600 seats at the same time? Defining these security needs from day one, that is the first pillar. Then we have Pillar 2, secure design. This is all about having an active mindset. You have to constantly be asking, how could an attacker break this? This whole process is called threat modeling. It's where you deliberately think like an attacker to find the weak spots in your design before they become a real problem. And finally, Pillar 3 is the secure development lifecycle. What this really means is that security isn't just a final check you do before launch. No way. It has to be woven into every single phase of the process, from that first spark of an idea all the way through deployment and beyond. So we have our three pillars: solid requirements, a secure design process, and a secure lifecycle. But what does that actually look like in practice? Let's break down the concrete steps you can take to build that secure foundation. Okay, here's a practical checklist. First off, use that threat modeling we talked about, especially for critical things like how users log in. Second, create a library of secure, pre-approved components so you're not reinventing the wheel and introducing new risks. Third, build security right into your planning. Your user stories should literally talk about security. Fourth, write tests specifically designed to try and break your defenses. And finally, from the very beginning, make sure different parts of your system are walled off from each other. So after all this, what's the big takeaway?
Why does this whole idea of insecure design matter so much, not just for the security nerds, but for literally everyone involved in building software?
This quote really cuts right to the heart of it. For years, everyone's been talking about shifting left, finding bugs earlier in the coding process. But that's not good enough anymore. We have to shift even further left, all the way into those pre-code activities like design and requirements. Security has to start before a single keystroke.
And that really leaves us with one final crucial question. I want you to think about your own projects. Think about their foundations. Is your application's blueprint actually safe? Or is there a disaster just waiting to be built?